Welcome back. Today is day 3 of our trigonometry unit. We will be defining our 3 trig ratios. We will be also using GeoGebra app to provide a visual of our ratios and check for understanding using Desmos. Hope you enjoy the lesson. What did we learn last class? So last class we did a trigonometry investigation, and I like the responses you guys gave us. So we had some good responses. I'm going to go ahead and read some of these. It says we learned about the opposite side and adjacent side. You write a little fraction, so like opposite side divided by the adjacent side, or also called the tangent ratio. So very good. And someone also wrote, also called TOA. All right, so tangent is the opposite over adjacent. So again, I like that, you got the kind of the meat of the activity was to know that there is some ratio called tangent, and it just represents the opposite side divided by the adjacent side. That's it. I learned that the tangent ratio is based on the degree of the reference angle. I like that a student is saying that based on the reference angle, I will get a tangent ratio. So it's based on one's based on the other one. So that is really good, especially when we start going to the higher math. That's a great explanation there. I learned about the ratios and writing fractions. I still need help, but I'm getting it little by little. I like this reflection. So I really like this reflection that the students knows what they're learning and knows that they're still a little confused, but they're starting to get it. But I also like that they notice that this is all about ratios or writing fractions. So they're noticing this unit is probably going to be mostly about writing ratios or fractions. I learned that the tangent ratio is the opposite side divided by the adjacent side, and regardless of the degree, the ratios will be the same. So I think that what this student is trying to say is when we were changing the triangles around, and we made the triangle bigger or smaller, as long as the angle stayed the same, then the ratios didn't change. So we'll take a look at that again today. I learned that the opposite side and adjacent side is called the tangent ratio. So great job. So it looks like we, majority of us understood what we're trying to learn, and you'll get better and you'll figure it out as we go too. So, but some great responses. Thank you. So in this activity, we're going to be doing, what I'm going to have you do is mess around with this app, play around with the app for a little bit, and I need you to tell me, write 4 to 5 sentences about what the applet is trying to show you. Be sure to include what the slider does. So there's 3 sliders on top. There's a green one, a red one, and a black one. So tell us what those do, and describe what happens in the picture too. So things move around, and they're supposed to describe it also. Be sure to define any new math terms. So if you notice anything new in there, define that too to your best ability. That would be awesome. So I'm going to have you guys go ahead and mess around with that, and let's see how it's going. All right, so here's the app right now. I zoomed in a little bit. Let me just play around with a little bit. So you see, you can grab the white points and move around the triangles, make it bigger, smaller. So I could, make this triangle taller, shorter, narrow, or wider. I could zoom in on the picture too. I could move the picture a little bit, I believe. So anyway, so there's my picture. Here's what we did the other day. So we messed around with the black slider. So when we moved the black slider, guess what side moved? The opposite one. And it was moving until it got over into the red part. And so remember what this is. This is the tangent ratio. It's comparing the opposite side to the adjacent side. So the opposite leg to the adjacent leg. And look what happens when you do that. What do we think the answer is? Well, the opposite side is a little bit shorter than the adjacent leg. I would say it's about, it looks like about 60% about 75. Yeah, maybe about 70%. It's about 70% of the way. So I think the ratio is going to be like 0.70 or somewhere right around there. Let's take a look. Ooh, close, 0.66. All right, so remember, that's the tangent ratio. That's the one we were learning on. All right, perfect. So let's continue on. So now, what does the other sliders do? So let's reset this. Let's start all over. And let's take a look right now at the green slider. So what does the green slider do? So let's see what it's comparing. So again, and you notice what piece is rotating? The opposite leg is rotating. So the opposite leg is rotating until it gets closer to the hypotenuse. So it looks like this time the ratio that we're going to be comparing is how does the opposite leg compare to the hypotenuse? And from this example right now, I noticed that it's a little bit more than halfway, so about 0.55. Let's say that might be correct. Oh man, I was pretty good on that one. So the ratio for this problem is going to be, and you notice there's new words here. There's a little word sin, so that stands for sine. So sine of 33 degrees is going to be 0.55. And like our student told us in the little response yesterday, was we can make this bigger or smaller, and look at it, it's not going to change. The ratio is not changing. But if you move and make the reference angle smaller, so let me look at, now I'm making my reference angle smaller, now the ratio is changing. Okay, so again, I like that someone said in their response the other day was, hey, the ratio is based off of your reference angle, and that was a great summary of that lesson. So sine, we're going to write this down a little bit, but sine, you should notice, is your opposite to your hypotenuse. That's the comparison we're doing. So there's only one left that we're going to study this year, and that's going to be this red one. So let's see what that's moving. And that one is going to compare, and look at it, it's comparing your adjacent leg to the hypotenuse. So now we're having a different comparison. Adjacent leg to hypotenuse, and that is going to be 91%. So it's almost the whole way for this problem. All right, so again, this is a new one, and this one is going to be called cosine. The COS stands for cosine. So we'll write that down in a little bit. But play around with this, see how you like it. See if you can start estimating, get pretty good at estimating what ratio we're talking about. I think this makes it nice and easy to see. So I hope this helps you. All right, so let's go ahead and record our thoughts on this one. So trig ratios. So the ratio of the length of two sides of a triangle. So when we study trigonometric ratios, we're talking about the ratios of sides of right triangles. The most common ones are sine, cosine, and tangent. And what you should have seen from our little response earlier was that there's three of them. So there's sine, and when we press it in the calculator and we do it, it's going to be sine, S-I-N. It's going to be just three letters. All right, there's also cosine, but we're only going to use three letters, so it'll be C-O-S. And then tangent, we're only going to use three letters, so it's just T-A-N. All right, so there's the three ratios that we'll be using, and you'll see these on your calculator. You'll see this on the calculator when you're looking for it. All right, so that's what you'll see. Now, one way to remember this, as soon as you start doing enough problems, you'll remember it. You'll memorize them. But an easy way to do it is to use it in mnemonic, kind of like remember PEMDAS. Some people used to teach that back in the day. Also, SOHCAHTOA is the way we teach this one. So if you can remember SOHCAHTOA, that will help you write all the equations that we need to know. So let's go with the first one. So sine. And let's do the SO part. So. What does that stand for? That tells us S stands for sine. So that's how we remember what ratio we're going to use, sine. And then we're going to have some reference angle. So the reference angle will always be here because we need some reference angle, or else we don't know what we're referring to. So sine of some reference angle. And that will be equal to, and we use the letters right here, the O and the H, to write the ratio. So is opposite divided by hypotenuse. And that's it. That's how we use SOHCAHTOA. So, it's real easy right now. Just memorize SOHCAHTOA, and then you'll get this. Let's do cosine. It's ka. So ka. So what does the ka stand for? Well, the C stands for the cosine. We need a reference angle, because remember, everything's based off of that reference angle. And then the ratio is A and H. So we're going to use the A and the H to write my ratio. So again, it's not going to be too tough for you to memorize this. We should be able to memorize it in one minute. SOHCAHTOA. Just remember, write that down on your paper, and then go ahead. A lot of my students actually do that on their test. I see on their paper, like SOHCAHTOA on top of the paper before they take their test. All right, so tangent. What is tangent? Tangent is going to be based on some reference angle again. And then the ratio is opposite over adjacent. So opposite over adjacent. Opposite divided by adjacent. So there's my ratios. That's how you use SOHCAHTOA. So when you see SOHCAHTOA, it tells you what fractions to write. It's going to help you out. Say, this is the fraction that you're going to write, and this is the ones we need to solve the problems. All right, so make sure you have this in your notes. That would be nice to refer back to whenever you're stuck on how to do these problems. So Let's try a problem. Let's try a couple. In this problem, we want to find sine x, cosine x, and tangent x. I'm just going to rewrite those over here correctly. I have a little mistake there. So I want sine of, remember we said angle x, so there needs to be an angle x that we're looking for. I'm going to want cosine in this problem of angle x. That's going to be my reference angle. So I need you to, let me rewind, go back one step. I wanted to make sure I highlight that. The student that said that there's a relationship between these two did a great job. They said there's some relationship between our reference angle and our ratios. Okay, so they were saying that they noticed from our activity that based on the reference angle, we were able to connect some ratios to it. So that's a great job. I just wanted to say that one more time. So when you're doing these problems over here, tangent of some reference angle, we need some reference angle, so that's what's in the parentheses. So my reference angle is angle x, and then we can finish this up. So let's go ahead and finish this up. But before you can do that, you need to actually identify your reference angle. There's my reference angle. Here's theta. And then we can label our sides. So remember, the hypotenuse is the longest one, always across from the 90. So I got that. And then my opposite is this piece because it's opposite the theta, or my reference angle. And this is my adjacent piece. All right, once you have those, you can write your ratios and you'll be good. So sine. We just learned it, so it's going to be hard to remember. So let's write it down. So, toa. And sine is going to be opposite over hypotenuse. So all I need to do is identify the opposite side and the hypotenuse, and I'm done. So this is going to be 8 over 17, and I'm done with that one. Check. Cosine. You want to figure out what cosine is? This is the ratio that is the adjacent over hypotenuse. So 15 over 17. This is how easy this is. This was like my favorite chapter, like in geometry back in high school. So simple for me. And tangent was opposite over adjacent, so that is just 8 over 15. Whoa. 8 over 15. Boom. And then the problem asks you to write as a decimal. Just punch in a calculator if you need to. But that's how you would figure out your answer. All we're doing is checking to see, can you write the ratios that we're asking for based on the triangle. So let's try one more. This time we're just changing the problem, but we're going to be using our reference angle. This time our reference angle will be angle y. So reference sine of y, cosine of y, and tangent of y. So let's take a look at this one. So if my reference angle is y, so this is my reference angle up here, it's this one. That means my hypotenuse is here, that's obvious, and opposite is this one, and this is adjacent, okay? So labeling your triangle is going to be the best part here. Once you label it, then you should be able to crank through the ratios, no problem. And again, we just learned SOHCAHTOA, so I'm going to write this down again, SOHCAHTOA. And sine is the opposite over hypotenuse, so find those pieces. Well, that's 20 divided by 25. There's the ratio I was looking for. The next one, cosine, is just a different ratio. It's adjacent over hypotenuse, which is 15 over 25. And lastly, tangent is just a different ratio. It's the opposite over adjacent, which is 20 over 15. And we're done with this problem. If you want to write it as 4 decimals, go ahead, plug in the calculator, see what those values are, and you'll get the ratio. All right, I hope you enjoy this. I have a little practice. So there's a little Desmos activity created by Mr. Chang where you can actually practice this, and we can see how you're doing and see what you understand. All right, but good job. Hope you enjoy the video.